Let's talk about latency first, because this is also something which is in the ballpark of Akamai, what you folks do with your footprint and presence. Why is latency becoming such a defining issue for enterprises when it comes to AI inference? And how can Akamai address that challenge?
I think answering that question really comes down to asking yourself, what use case and what set of users are you expecting to serve with your AI application? And I think once you can answer that, distinctly and uniquely well, then you really have to start treating this challenge like any other sort of an infrastructure and architectural challenge. So for example, if when you build your proof of concept, you are attempting to serve an answer to people in a given region, then you should probably be thinking, if that is going to be my target demographic, then I need to make sure that I have infrastructure and failover capabilities to uniquely serve that region. However, what we find is still, because of the pervasiveness of deployments and the way that people tend to think about a couple of centralized locations to deploy their models on hyperscalers in the US and even in places around the globe, Amazon US East is a very heavily used data center. It's a default for many people to think about. It's where they deploy a lot of their code. The problem is, before you start thinking about privacy and sovereignty and how your data needs to be routed and even latency concerns, you have to ask yourself, are the people that I'm serving going to be served successfully and effectively from US East or Virginia in the United States? And if the question is no, you need to stop right there and then think about, how am I going to be architecting for the constituency that I'm trying to reach? Beyond that, though, I do think that people wait too long to think about scaling events, whether it's scaling up infrastructure capacity for additional CPU or memory headroom, for example, or GPU headroom, or if it's scaling out when you need to get closer to users. People have a tendency to do this in the wrong order. They think they'll build the proof of concept, engage their target audience, get to a certain number of critical mass of users, and then start to scale out. And the problem is, you might never hit that scaling opportunity if you can't provide the sort of experience that people expect. And so I think the thing is, you're not really thinking about latency in the right way. It's not a tuning problem to make something that might be too slow go faster. It might be a fundamental characteristic of the architecture you're building, in which case you have to think, you can't architect your way out of physics. If I have to get a round trip time from a location to a destination, you can test that without your full AI proof of concept. Then you add in, how long does it take? The question that I'm answering, the tokens that I have to stream back to get a response for the query that I'm building, and add that to whatever your round trip latency time is. And in many cases, that is taking some of the lessons that we've learned from building the last 15 to 20 years of the internet and paying those forward to think about, again, client server architectures and networking times, because from the latency perspective, it really is milliseconds that matter, and the speed of light is going to get in the way of those milliseconds.